Now in the next case, if we consider the same wire but it is carrying a current I in the upward direction, then as you can see here, it is pushed towards the right due to the force, the magnetic force acting on this wire. Now let's see why it is pushed towards the right. Uh, you can use all the other rules, including the Palm rule, the Fleming's left hand rule, and even the cross product rule to determine the direction of the force. But there is another way to look at this force, or to find the direction of the force, and it is if you see that if the current is moving upward, and if you determine the direction of the magnetic field which is produced by this current in the upward direction, for that purpose we will use the simple right hand rule, in which you will curl the fingers of the right hand around this wire, and the thumb will indicate the direction of the magnetic field. The thumb will indicate the direction of the current flowing in this wire. So since the current is flowing in the upward direction, then curl the fingers of your right hand in this direction such that the thumb is upward. So this is the direction of the magnetic field which is produced by the current in the wire. One magnetic field is this one, which is the applied or external magnetic field B, in which this conductor is placed. The other magnetic field is produced by the current flowing in the wire, and the direction of that magnetic field B is obtained if you hold this wire in your right hand such that the thumb indicates the direction of current. Then the curled fingers around this wire will give you the direction of the magnetic field lines around this wire, which is produced due to the current flowing in the wire. So this is the direction of B due to the current in the wire, and here you can see this magnetic field line is entering in on the right side and is emerging on the left side. So here we will put a cross to show that the magnetic field line is entering, and here it is emerging out. So this is forming a ring around this wire, and the magnetic field in which it is placed, in which this wire is placed, is pointing out of the page. So if you see on this side, here is cross, here is dot. So one magnetic field due to the current is inwards, and this magnetic field, which is the external applied field, is outwards. So here these two fields are cancelling each other, and on this side the magnetic field due to current is out of the page, and the external magnetic field is also out of the page. So the two are strengthening over here. The two magnetic fields are being strengthened on the left side, and they are cancelling each other on the right side. So this wire will be pushed from the stronger region to the weaker region, from a region where the magnetic field is strong to a region where the magnetic field is weak. So it will be pushed in this direction. The wire will be pushed in this direction. That is, this is the direction of the magnetic force acting on this current carrying wire placed in the magnetic field, which is directed out of the page. So that is why it is shown pushed towards the right. Now consider this case in which the current is flowing down. So what will happen? Now you hold this wire with your right hand such that now your thumb is directed downward. So the curled fingers around the wire will be curled in this direction, and this is the direction of B, or the magnetic field which is produced by the current flowing down in this wire. So this is the field of this current carrying wire, and this is the magnetic field or the external field in which this wire is placed. So here the direction of the force is this. The direction of the force acting on this current carrying wire is this. Now why this is so? Because the magnetic field B, which is in form of ring around this current carrying wire, it is that field line is entering over here into the page and coming out of the page on this side, entering on this side and leaving the page in the outward direction on this side. So here we will show the direction of that field by cross, because it is into the page in this direction towards the left of the wire, and it is out of the page on the right side of the wire. So on this side of the wire, the two fields, that is the field due to the current in the wire and the external field, are in the same direction, out, both are out of the page. And on this side, this field which is due to the current in the wire is into the page, and this applied field is out of the page. Here they are cancelling each other, and here they are strengthening each other. So the right side of this wire is the stronger region of the magnetic field, and the left side of the wire is the weaker region of the magnetic field, and the wire will be pushed from the stronger towards the weaker region. Now here you can see that in both the cases the value of the magnetic field or the external magnetic field B is the same over here. The magnitude of the current is also the same, that is I is the same over here, and the length of the wire is also the same, but the direction of the force in the two cases is opposite to each other. Why this is so? Because we have reversed the direction of the current over here. In one case the current is flowing up, the other case current is flowing down. So it means that by reversing the direction of current in the wire, the direction of the magnetic force acting on that current carrying wire will also be reversed. Similarly, if you do not change the direction of the current and you just reverse the direction of the magnetic field, that is, if here the direction of the magnetic field is into the page, then what will happen? If this direction, instead of being out of the page, is into the page, now what will happen over here? On this side the two fields will cancel, and on this side the two fields will strengthen each other. So this region will become stronger and this region will become weaker, and now this wire will be pushed towards the right in this direction. So again the direction of the force will reverse. So it means that the direction of the force reverses if we change the direction of the current, or if we reverse the direction of the current. And if we don't reverse the direction of current and just reverse the direction of B, that will also reverse the direction of the magnetic force acting on that current carrying wire. And if we reverse both, that is, if we reverse the direction of the current as well as the direction of the field B, then the two negatives will give us positive result, that is, the force, the direction of the force will not change. That is, if in this case we reverse the direction of the field B and now it is into the page, and if we also reverse the direction of the current as well, then in this case the direction of the force will not be changed, that is, it will still be towards the right. So this is all about the magnetic force acting on the current carrying wire. In the last slide